This is my fight song, 6.2, Parallelograms. All right, so as you know, we're moving on to the new shape with one extra side that is called a parallelogram. Most of you guys know a parallelogram to look like this. Parallelograms can also look like that. You might think, well, no, that's a rectangle. Guess what? All parallelograms all rectangles are parallelograms, and this too. You might think, oh, it's a square. Yep, it turns out that all squares are parallelograms. Let's look at the definition of a parallelogram to see what I mean. All right, a parallelogram is a quadrilateral. So a quadrilateral is any shape with four sides, with both pairs of opposite sides parallel. So you have this side parallel and then this side parallel. So as long as you have two pairs of parallel sides, you have a parallelogram. So that's why we had the rectangle and the square, because they also had both sides parallel. All right. Now I'm going to throw you a whole bunch of theorems and rules about a parallelogram. So write these down because they're important. They're basically properties of a parallelogram. All right, the first theorem is opposite sides theorem. If a quadrilateral is a parallelogram, then both pairs of opposite sides are congruent. So there was a typo. All right, if a quadrilateral is a parallelogram, then both pairs of opposite sides are congruent. So that just means that this side is equal to this side, and this side is equal to that side. It has to be both pairs. It can't just be one pair. That's important. Here is the next theorem for parallelograms. If a quadrilateral is a parallelogram, then both pairs of opposite angles are congruent. So you have this angle is equal to this angle, and this angle is equal to this angle. All right, again, both pairs of angles have to be equal, not just one. All right, the next rule, consecutive angles theorem. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. All right, first you have to remember that supplementary means they add up to 180 degrees. What has to add up to 180 degrees? Consecutive angles. This angle right next to this angle, they have to add up to 180. Not only that, this angle with this angle needs to add up to 180. And then around the circle, this angle with this angle need to add up to 180, and then these two have to add up to 180. All right, so two in a row have to add up to 180. And then this is the last rule, this last theorem for parallelograms, the diagonal bisector theorem. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So there's the diagonals. According to this theorem, this piece equals this piece. Remember, bisect means cuts in half. So those two pieces are equal. And this piece is equal to that piece. All right, and so those are all the rules for a parallelogram. There's a lot of them. Usually I would spend a couple of days talking about each rule, but now I'm throwing all the rules at you at the same time. All right, let's go ahead and do a fairly easy example. Here I give you a parallelogram. It says given MATH is a parallelogram. So that's the symbol. This right here is the symbol for parallelogram. So as soon as I give you something as a parallelogram, then all of those rules that I just said are now true. If I didn't say this, then none of the rules would have been true. But now that it has been said, then you can use all of those rules to find angle H. I know that looks like less than H, but it's meant to say angle H. All right, how big is that angle? Well, if all of those rules are now true, then this angle with this angle must add up to 180, the consecutive angles theorem. So therefore H must be 50. How about HT? How long is HT? That one's easy. It must equal 7, opposite sides theorem. How about MH? Let me erase some stuff so it doesn't look so messy. MH was right here. It must equal 3. Again, opposite sides theorem. How about angle T? If we look at angle T, we should know that it is 130 degrees, opposite angles theorem. Opposite angles theorem. And then angle A. Well, again, these two must add up to 180. So then angle A is 50, consecutive angles theorem. All right. So I think the example is pretty easy because it basically just goes through all of the properties, and so you just have to remember all of those properties. All right, let's throw in some algebra into this. You have to solve for x and y. I forgot, this is important, but the shape you see is a parallelogram. If I didn't say that, then none of the rules would work and you cannot do this problem. All right, so yes, this is a parallelogram. Let's go ahead and solve for x and y. I see there's more y's in the problem, so maybe I'll focus on the y first. What do I notice? They are consecutive, so together they must be supplementary. So there it is, 5y minus 30 plus y plus 12 equals 180. Use a little bit of algebra. Solve it out. You should get y equals 33. All right, that's nice. 33 is easy enough. Now we have to look at x, and there it is. It's right here. There's a few ways you can do it. I'm going to go ahead and use this one, the opposite angles theorem. These two should equal each other. Well, if y is 33, then y plus 12 must be 45. Set them equal to each other and solve. Not that bad at all. All right. All right, so this is our last slide. It's a proof. I know you guys are not big fans of proofs, but we're going to have to continue to do them so that you get a little bit more comfortable with working with them. Let's see. It says the given PRVU and VETI are parallelograms. All right, so that means that those two shapes that you see up there have all the rules applied to them now because they are parallelograms. All right, we're going to somehow use some of those rules to show that angle P is equal to angle T. All right, let's strategize and see how we're going to do that. All right, the first thing you always do, you know, PRVU and VETI are parallelograms. That's just given, nice and easy. What can we do next? Let's say angle P is equal to angle RVU. RVU is right here. So these two angles are equal to each other. Why are they equal to each other? Opposite angles theorem. We know that in a parallelogram, opposite angles are equal. Now, here's a side note. Why did I use one letter to describe angle P, but then I had to use 3 letters to describe angle RVU? The reason is, and I've said this before, is that P, there's only one P angle. But I can't say angle V here because that's, I don't know, is this angle V? Is this angle V? Is this angle V? There's too many angle V choices. So when there's too many choices, you have to use 3 letters to be more specific. And I used R, V, U. So notice how I drew in the angle. The way you draw in your angle is the way you name the angle. So that's why that one has 3 letters. All right, so we have those 2 angles. This angle is equal to this angle. Now what can we say? Angle RVU is now equal to angle EVI, this one. How do we know they're equal? They're vertical angles. All vertical angles are equal. Let's keep going. Angle EVI is equal to angle T. Why is our EVI equal to angle T? Again, it's a parallelogram, so opposite angles are always equal to each other. Wow, we went from P to the middle, and then across, and then to the end. So we can conclude that angle P is equal to angle T. So we basically went from P and went all the way to T, and that is called the transitive property. All right, that is all we have for today. Go ahead and try the homework.